Hello friends, in my last video I explained the first part of classification of polymers, where we looked at the classification that bases on the structure of the polymer. In this case we talked about homopolymers and copolymers. We also talked about the classification that bases on the origin of the polymers, where we talked about natural polymers and synthetic polymers. We are going to continue the same classification by looking at the classification bases on molecular forces. When we look at the molecular forces between the polymer chains, we can talk about thermoplastics. Thermoplastics are those polymers that soften or melt when exposed to heat and then harden into new shapes when cooled. Look at the example of polythene bag or the cover of your pens. You know that when you expose it to heat, it becomes soft or it melts, and you can give it a given shape, and then when it cools, it takes that new shape. It hardens into that new shape. This characteristic is caused by the weak intermolecular forces that exist between polymer chains, and it is caused by the presence of the linear or slightly branched polymer chains that we have in thermoplastics. Here you can see this is a structure of a thermoplastic, where you can see that the polymer chains are linear. There are no branches between the molecules of the thermoplastic. So this property makes them easily be remolded into different shapes and many times. It means that thermoplastics can easily be recycled. When they get old, you can use them again to make new materials by melting them and then mold them into another shape that you desire. We have the examples for the thermoplastics. First of all, we can say that most of addition polymers are thermoplastics. Specifically, we have polythene, we have polystyrene, we have polyvinyl chloride, and so many others. We also have what we call thermosets. Thermosets are those polymers that harden or set into new fixed shapes when they are exposed to heat. Let's take the example of the yolk of an egg. You know that when an egg is not boiled, it is raw. Of course, it is very soft and viscous. But look at what happens when you boil it. When you expose it to heat, the yolk of an egg takes an elliptic shape that is hard, and you cannot melt it again. So when you continue exposing it to heat, it does not change the shape, it remains with that shape. The real cause of that is that the polymer chains interact with the strong intermolecular forces, and they contain a high degree of cross-linking between the polymer chains. So when you expose it to heat, there is intensification of the cross-linking. So meaning that the cross-linking increases when it is exposed to heat. The fact that it cannot melt when it is exposed to heat and cannot be remolded into another shape makes them not recyclable. So thermosets are not recyclable. Examples are bakelite, the yolk of an egg, as we have said, vulcanized rubber. You know that there are cross-links of sulfur in vulcanized rubber. When you heat it, the cross-linking between the molecules increases. So here there is an activity about this, where you are asked to identify the advantages and disadvantages for thermosets and thermoplastics separately. It means that you will find one advantage or two advantages of thermosets and two advantages for thermoplastics, as well as disadvantages for each of them. When we still consider the molecular forces, we can identify elastomers and fibers. Elastomers are rubber-like solids with elastic properties, and these characteristics result from the weakest intermolecular forces that exist between polymer chain and which permit them to be easily stretched when a tension force is applied. Again, a few close links that exist between polymer chains help them to retract to their original positions when the tension force that was applied is removed. Check the example of vulcanized rubber. You use rubber in different activities. I know very well that when there is a tension force that is applied, they change their size. They extend or they expand in volume. And when this is removed, they regain their original position. For fibers, for them they are thin thread solids which possess high tensile strength and high elasticity modulus. It means that they resist the tension force. It means that when you pull them, of course, they don't extend in size. That's what characterizes the fibers. This characteristic results from the fact that the intermolecular forces between the polymer chains are very strong. In most cases, they are hydrogen bonding or strong dipole-dipole attractions. Here we have the examples of nylon 6,6 or Daclon. So you know that this nylon really is very strong in a way that it is even used to make these strong ropes that the soldiers use when they are climbing the mountains or when they are doing other exercises or practical activities of theirs. The activity here that you have to think about is just to explain the properties that makes vulcanized rubber be used to manufacture inner tubes of tires and balls. What properties that rubber have that makes it be used for this purpose. Number two, you are going to defend how nylon is the most preferred option over polyesters while making strong ropes. The last classification we are going to talk about is the classification of polymers by basing on the effect of microorganisms. Here we identify biodegradable and non-biodegradable polymers. Biodegradable polymers are those polymers that decay under the effect of living microorganisms. So they are easily hydrolyzed by the enzymes of the microorganisms and they are chopped into small molecules or small compounds. They are environment friendly because they don't accumulate in the soil for a relatively long time. But this also has an inconvenience because those polymers that are used to make some materials like banana fibers that are used to make handbags or other items, they don't last for a long time because they easily get spoiled by decaying or by biodegrading. Here the examples are most of natural polymers such as starch, cellulose, proteins. All those natural rubber, all those can easily decay. Non-biodegradable polymers, for them, they cannot be decayed by living microorganisms. For that reason, they are responsible for solid waste accumulation in the environment that is there for a long time. So they are very harmful to our environment. When they are old and we throw them in the environment, they cause a lot of problems. But also they have an advantage for this because we can use them to make durable materials which can last for a long time, that we can use for a very long time when you compare to biodegradable polymers in this case. Here, most synthetic plastics, most synthetic polymers are non-biodegradable. We have polyethylene, we have polystyrene, we have polyvinyl chloride. We have many of them are non-biodegradable and they cause a lot of problems to our environment. So here there is an activity about this. You are asked to explain why some countries have policies that ban the use of plastic packaging like polythene films. Number 2, you will use a scientific argument to explain any inconvenience of using biodegradable polymers in our daily life. So this is what I had to talk about in regard with the classification of polymers that remained the last time. I think you have enjoyed the session. Thank you very much.